Welcome to Rejected Religion, Patreon Tier 3, the Garden of Arcane Delights. My guest this month is Dr. Dean Radin. Welcome, Dean.
Thank you. It's good to be here.
It's very good to have you here. I'm very grateful that you've agreed to talk with me this evening. At least it's my evening time due to the time difference. For you, it's morning. I came into contact with you through RENCEP, the research network for the study of esoteric practices that has funded, along with the Bial Foundation in Portugal, a study that investigates the efficacy of SIGIL Magick. But before we go into more detail about that, I'd like to begin by asking you some other questions first that provide a context for all of that before we get into the actual talking about the experiment itself. If that's okay with you?
Sure.
Okay. You have been studying the relationship between science and magic for some time now and have written numerous books on different aspects about this, as well as psychic phenomena. And you've noted that this phenomena has been empirically confirmed by many, many different experiments. Yet it seems to me, as far as I can tell, that the general public isn't really aware of this evidence. And the running narrative regarding the types of phenomena that would be considered, quote unquote, paranormal, anomalous, or psychic is still considered to be relegated to the areas of superstition, charlatans, and even conspiracy theory. And I find this to be unfortunate because, as you state, there is empirical evidence. Yet it seems as if the scientific community is rather reticent to talk about it, perhaps. But my question to you is, in your opinion, why do you think that the theoretical explanations as to why this type of phenomena could be occurring slow to emerge from the scientific community?
Well, three reasons: taboo, culture, and worldview. So they all conspire to make science not quite what science aspires to be. And by that I mean that throughout history, people have made observations of things that were not well understood. And the scientific community then responded to it, well, if you can't explain what those observations are, according to what we currently understand, we won't pay any attention to it. So right. One example is continental drift. So people had noticed that it looked like the continents used to be connected, simply like a jigsaw puzzle. Mm-hmm. But the scientists at the time said that's ridiculous. The land masses don't move. And so what's your explanation for why there's this strange jigsaw pattern? There isn't any. Therefore, your hypothesis is wrong. Well, later on, science marches on and we figured out how that happens. And then suddenly it's okay. And if the person who suggested this lived long enough, he would have found that, finally his hypothesis was accepted. Another famous example is meteorites. And people were claiming that there are things falling out of the sky. And people said, no, that's impossible. There is no rocks in the sky to fall. And then eventually we learned that, there are rocks in the sky that fall. And then a more contemporary example, besides psychic phenomena and magical phenomena, are UFOs. People throughout history have reported strange things flying in the sky. Yeah. And the scientific response is, there are no such things because you can't explain what that is. Besides that the nature of the evidence usually is a little bit blurry. Maybe that is not the case, given recent government disclosures about what's going on.
Right, yeah.
But nevertheless, from a scientific perspective, a stigma arises around observations where there isn't a clear explanation that is already provided within what science knows, which from my perspective is completely backwards. It means that you can't accept what people observe unless we already know what it is. And it sets up a paradox.
Right.
So that's it's partially that. There's a culture issue as well. I've spent some time in India and Southeast Asia, and things like psychic phenomena are not simply accepted by the general public, as it is everywhere, but even within the scientific and academic communities. In fact, it's so well accepted in India that when I've talked about these topics in Indian universities, I would ask, would you be doing interest? Would you have any interest in doing this kind of studies? And even though there's full acceptance of the phenomena, the topic doesn't fit within current disciplines, because the disciplines in India and universities match those in the Western world. So there is no department of parapsychology except for one. Andhra University has a department of psychology and parapsychology.
Oh, okay.
So there, it is okay to study these kinds of phenomena, even though most people don't, because there's not much support for it.
Yeah.
But nevertheless, culture makes a big difference in terms of what things are considered to be allowable. And then the third factor is worldview. So worldview develops from what the culture at large decides this is the way that we understand reality. And there are a number of different worldviews. If you're a religious fundamentalist, you have a certain way of thinking about who you are and your relationship to the world. If you're a scientist, typically it's a different worldview. If you're a lay person, a different worldview. Each of these worldviews allow certain things to exist. And so if someone is presenting something to you that's not part of your worldview, your response is kind of, as you said, it would be that it can't be, therefore it isn't. And therefore you must be lying, it must be fraud, it must be something other than what you're talking about. And it's completely, that is very predictable based on where you're coming from. What do you think reality is?
Do you see, because you're right in the middle of everything, do you see changes happening now, or is it really slow to shift these really cemented ideas almost?
The scientific worldview has been moving slowly away from what we might call reductive materialism as the only valid way of understanding reality. That change has significantly accelerated, I would say, in the last 10 years.
Oh,
very significantly.
That's positive.
So I have a book coming out later this year. This is 2025, which is another book on magic. It's a second book on magic that I've written. And the reason why I wrote this is because the first book I wrote was in 2017, even though the book was published in 2018. And at that time, it was already clear to me that there was this shift happening, a paradigm shift. But that has accelerated. And accelerated to the point where I felt it was time to write another book, because you think about how things change, especially in a sociological way, it sort of bubbles along for a long time, maybe slowly changing, and then it starts accelerating. And so we are at the knee of the curve. So we're about to experience a very fast change at this point. The reason I say that is because when you look at thought leaders and physics, and in the neurosciences in particular, they're now openly talking about going back to what, in this context, we would say are esoteric ideas. Ideas like idealism and panpsychism and so on.
Right.
Those are now being talked openly, right? This is not secret things that people are talking about only in the closet, but open articles by people who are leaders in these fields. That means a combination of younger people who are not tied into the dogma of the past, but more importantly, the arising of things like quantum biology, and also the finally recognized difficulty in understanding the nature of consciousness. That's where a lot of this is coming from.
Right. Well, this is good news, very promising. Just checking my notes here. The new book of yours is called Enchantment, if I'm not mistaken?
Yes.
And that's coming out later this year.
Yes.
Okay, I'll be certain to list that in the program notes so that people can check that out once it is available.
I have a preliminary cover, which is quite nice, but the subtitle hasn't been settled upon yet, so I don't know what the subtitle is.
All those little fine details that have to be decided. Yes, okay. So you've talked about the connection between magic and science a lot, and you have listed the three main classes of magical practices as 1, divination, 2, enchantments, and 3, theurgy. Would you explain what you mean with these terms, as well as how these relate to the scientific study of psychic phenomena, which also has 3 classes that you list under clairvoyance, psychokinesis, and survival after death? I saw you in another presentation that you were giving talk about this, and I thought this was really interesting, and I think my listeners might appreciate this as well.
So the 3 classes in magic are, I would say, exactly the same as clairvoyance or divination, as divination, and psychokinesis, mind-matter interactions as enchantment, and survival evidence for theurgy. They're the same thing. They're looking at the same phenomena from different perspectives.
Right.
A kind of scientific perspective in one case, an esoteric direction from another case. The phenomena are the same. So one of the differences is that from a scientific perspective, a lot of the effort has been to establish whether these things exist, because they do challenge the existing scientific worldview. Even though it's changing, it changes really slow. So that has, since at least the middle of the 1800s, has been obsessed with the idea of whether this can be true. More recently, within the past maybe 4 or 5 decades, a lot of the researchers who are active in this field are more interested in how does it exist? Because the proof-oriented studies have shown we don't need to do proof-oriented studies anymore. Maybe somebody who doesn't believe in any of this needs to do proof-oriented studies to get to the point where they can start believing in the data. But for the rest of us, we're pretty well convinced that these are repeatable effects. They tend to be small in the laboratory, but they're there. We could see it. So then the question is, well, then how can we see it? And now we're going after explanations. How does this fit in with what we know? If it doesn't fit in with what we know, do we need to develop new things that we're going to know? It's ultimately saying, or maybe our philosophies have to be revised. So that's the connection then between psychic phenomena or parapsychology and magic. It is the same phenomenon looked at from different perspectives. The other thing is that magic typically is more concerned with pragmatic usage. It's about what is the practice of psychic phenomena? What do you do with this stuff?
Yeah.
It unfortunately, after many, many years of being suppressed in the way that it's presented in entertainment, it's presented as gigantic, enormous, easy, monstrous effects, usually devolving towards horror. That's the way that Hollywood works on this.
Yeah.
Well, it's like any capability or force, right? It can be used for horror, it could be used for healing. So healing side of these phenomena are not typically portrayed in the entertainment business because maybe it's not as exciting. There are a few movies that kind of go in that direction, but most of them immediately devolve into horror. And this infects the cultural mind because then people are afraid of it.
Yeah, exactly. Out of the many scientific experiments that investigate intentional effects on the physical world, which have developed over the years, you note that 3 stand out. The first being tossed dice, the second being random number generator outputs, and the third being photon interference. So could you first explain what these are about before we move on to talk about the third one in more detail? Because I don't know if the listeners would know. They might know the tossed dice, but they might not know the other 2, what those mean.
In 1935, a gambler went to J.B. Rhine's lab at Duke University. And the gambler said that he had the capacity to toss dice and control the output. And so Rhine thought, well, that's interesting. So he and his contemporaries began to study this idea whether dice that were tossed, where you would say, I want to get a 7 or I want to get some number, could you get that if you threw 2 dice? And then over about 50 years, many, many studies were replicated, becoming more and more rigorous along the lines because it was learned early on that if you could allow somebody to hold the dice and toss it, well, maybe they were manipulating it in some way. So that was no longer allowed. Now you had to put the dice in a cup and you had to shake it in a cup. And then later he said, well, even a cup is a little suspicious, so maybe we'll have a machine throw the dice. And then maybe you don't want people writing down the results, so we'll take photographs of where the dice land. And then you can't use regular dice. You need to use perfect dice where the sides are all balanced so that it has the same probability. All of these steps go along the way. It happens in every experimental realm where somebody says, well, maybe that's why you're getting that result. These are loopholes. So many, many loopholes were closed over the years. And the overall results, when you look at it from a meta-analysis, shows that, yeah, it looks like people really are able to will or intend that certain numbers come up more often than others. And you see that statistically. And overall, the results, I think, are pretty clear. It's clear. At the same time, it doesn't mean that the casinos are going to go broke. Because when you do these kinds of games in a casino context, there's every type of distraction you can imagine that is designed to make it difficult to intend. So free alcohol and scantily clad people and loud music and lights and everything, it's difficult to be able to maintain the kind of concentration that you would need in order to do this sort of task effectively. So that's dice. So the dice studies ran from about the 1930s to the 1980s. Starting in around the 1960s, late 60s, when electronics became easier to use, Helmut Schmidt, a physicist at the time at Boeing Research Labs, the Boeing aircraft company, he developed an electronic random number generator, which is essentially the same as tossing dice, except it's done electronically, and typically, rather than producing 6 numbers, it produces bits, zeros and ones. So he used radioactive decay, he used quantum tunneling, he used a variety of different methods to produce the randomness in this method. Also, with dice, you toss a pair of dice or a bunch of dice and you get some number. The random generators are automatic and can produce tens to hundreds to millions of bits per second and completely digitally recorded. Originally recorded on things like paper tape, but now you can get a tiny little stick that will produce millions of bits per second.
Okay.
So starting in about the early 70s, people began to switch over from dice to random number generators. And the task was more or less the same, except it generally was, you're now dealing with zeros and ones. So you would present the results of a whole bunch of bits. You add them up and present them on a screen, and they would have a squiggly line going up or squiggly line going down or across the center. And you would give somebody instructions to press a button. This thing can produce a huge number of bits. We'll show you the result on the screen, or maybe just as a number, and intend for the number to go up or the number to go down. And so if the number was going up, you'd have too many 1 bits. If the number's going down, you have too many 0 bits. And if you don't try anything, it should hover around 0, the same number of zeros and ones. So that has been done a gazillion times, hundreds of published experiments. Probably the best known were done at Princeton University over a period of almost 30 years. And the results of their studies were following this, what they called a tri-part protocol. Aim up, aim for ones, aim for zeros, and now don't do anything at all. Just let it go. And when you look at the final results, the graphs are pretty much like you'd expect. You're aiming up, the graph, after many people and many trials, starts to move up. And aim down, it goes down. Don't do anything, it hovers around chance. And the statistics of it are very clear that this is a real effect. We're talking about very small probabilistic changes of what's happening inside the random number generators to produce those outputs. The same is true of the dice studies. You see small probabilistic effects. You don't see things levitating or like we see in the movies, but you do see that the assignment of do this with your will changes the physical world. So, do we have a good explanation as to why that occurs? No. That's one of the reasons why this is considered controversial. It's very similar to continental drift. Yeah. Look at what happens. No, we can't explain it very well yet. Will we at some point? Absolutely. Right? It follows the same track that you see everywhere in history of some weird thing is happening. What is that? I don't know. Eventually, science will catch up to it. Sometimes by studying the thing itself, and sometimes by studying something else, and then people look at that and say, oh, you know what? That could explain that.
Right.
And that could happen as well. So those are the first 2 categories. The third category is relatively new. This involves taking advantage of the quantum observer effect, which is not understood, but it's well accepted in physics, especially quantum physics, not classical physics. In quantum physics, if you observe a quanta, meaning a photon elementary particle, if you observe an elementary particle, its properties change than if it's not observed. And this is partially because of the curiosity that a quanta, when not observed, doesn't have any properties, which doesn't make any sense from an everyday perspective. You look at something, you describe it by its properties, that this bottle weighs a certain amount and has certain colors and has certain sound and so on. And if that were a quantum object, it might have properties, but they'd all be scrambled together in a superposition, and it doesn't have any single property anymore. So there's something peculiar that happens when you measure or observe a quanta in which it suddenly gains properties. And now you can say, oh, I look at it and now I see what it looks like. And you can measure, and not only that, you can measure some of its properties, but not other properties. You observe it and you sort of collapse the thing that you observed into that particular property. It's no longer in a superposition of a lot of states. So this is a puzzle in quantum mechanics. One of the easiest ways to see this is in a double-slit optical system, where you have a slide, typically a metal slide with two tiny little slits in it, microns wide. They're tiny little slits. And you shine a laser through it, and the pattern of light that you see coming out on the other side is alternating light and dark bands. It's sometimes portrayed literally as light and dark bands, and it's sort of like that, but it's not exactly, because there's also diffraction going on, so it's too complicated to try to explain. It's easier to show. But anyway, so you would see this interference pattern, but only if you don't know which of the two slits the photon goes through. If you put a detector near one of the slits and it fires because it's a photon or an electron going in through one slit, that interference pattern goes away. And so now the light is behaving like a particle rather than a wave. And this is physics 101. It's easy to demonstrate in a lab. The question is, why is it that detecting a particle will cause the wave function to so-called collapse? Right? The quantum world is all about potentials and possibilities, waves, whereas the world we live in, the world of everyday experience, is about particles, things with specific properties. So what is it? Well, for a long time, people were saying, well, when you put a detector and it's detecting a photon, say, it's colliding with it. It's causing it to stop being wave-like because you forced it to become a particle. And so that's why this happens, because now you've kind of changed the nature of the photon as a result of detecting it. There's a bit of a problem with that. The problem is there are different experiments. Some are called interaction-free, and some are called negative measurements. So one way to describe this is you have two slits, you put a detector behind one of them, only one of them. You fire a single photon. And so let's say you fire it, the detector goes click, I see it. That forces it to become a particle. And that's what you'll see on the screen, a particle pattern. Now you do another one. You fire the photon, you hear nothing, which means it had to go through the other one. So it didn't interact with anything. It still looks like a particle. And the reason is that you can now figure out, because you fired the particle, you know that it hit the screen, you can logically figure out, I now know what's happening. So the underlying issue here is about what you can know.
Yeah.
Which is, so it's not simply a physical interaction, it's about knowledge. Well, what's knowledge? We don't have a good explanation for that yet, but it certainly sounds a lot like what we talk about when we say, well, oh, I see that thing. I'm observing that thing. I'm gaining knowledge about it. So it sounds like it might be related to consciousness. This gives rise to the consciousness collapse interpretation of quantum mechanics. So John von Neumann, Eugene Wigner proposed this idea that consciousness is the thing that takes the potential quantum world and turns it into the classical world that we experience. So this line of experimentation is saying, well, let's take that seriously, because most physicists don't, although beginning to change. What if the mind really were necessary, or at least involved in the transition from quantum to classical reality? If you can demonstrate that that was true, it suddenly opens an acceptable physical phenomenon to understand how psychokinesis works. because now it's saying, yeah, consciousness is related in some way with the way that the physical world behaves. And so in an experiment, you'd set up a double slit system. You ask people to either use their mind to imagine that they could get which path information, they could see the photon. Then you ask them to do that and ask them to withdraw their mind and go back and forth and see whether or not the interference pattern changes. So we've been doing experiments like that since 2008. We finally got other people to be involved in this, and so there are 5 laboratories so far that have reported replications of this kind of experiment. 4 of the 5 report significant results. It's difficult to do a meta-analysis of these studies at this point because the type of laser, the type of apparatus, there are many, many different things that people have tried. In our own lab, we've tried lots of things. And so they're not uniform enough to be able to say this thing can be replicated again and again, because this thing keeps changing as people are trying different methods to improve the results. So that's the new element here. So we go from dice as large physical objects to electronic random number generators, where we're talking about electrons ultimately, to photons mostly in an apparatus where you can talk about it in terms of physicists will at least understand why the experiment is being done. Because if you tell a conventional physicist, I'm going to toss dice now, and I'm going to try to move it with their mind, they will think you're crazy because they won't see any way that that's even conceivable. You talk about random number generators, you almost get a similar response, even though there's a huge amount of data saying that it's a real thing, because they don't know how to connect it with what they're used to. If you're not talking about an observer effect in an optical apparatus, they think, oh, okay, that's kind of like the delayed choice experiment, blah, blah, blah. It's like part of the discipline. And so that's one of the reasons why I moved from mainly using random number generators into the optical systems. And I would say there's a smidgen of a possibility that the results are actually stronger in an interference experiment. Maybe because it's closer to the raw quantum effects, but we don't know yet.
I see.
It's too early, even though I started this in 2008, and the first experiment of this kind was actually published in 1998. 20-some years is new in this kind of experimentation.
Right. Going back to the first 2 types of experiments, the dice and the random number generator, were the people that were involved in this, the participants that were trying to change the numbers or were trying to guess the dice, were these experienced people or were these people that just came up off the street and just said, oh, I'm going to give it a go? Or did these people have training in some kind? I'm using the word training kind of loosely here, but were these people that kind of had a knack for something or always thought to, oh yeah, I always have this ability to be able to predict things like the ESP and all that stuff. Like what do they call it? The Zellner cards or those types of things where you can like guess things ahead of a Zener. So thank you. So were these just everyday random people off the street or were these people that seemed to have a proclivity for this or both?
Both kinds.
Both. Right.
Yeah.
Okay.
So if the study is done in an academic setting, oftentimes they would select people who are simply willing to give it a shot. They would try it. Sometimes in those contexts and in other contexts, if there was enough money and time, you would run a whole bunch of people first to see if they were any good, and then you choose the ones who seem to have a talent for it. So that's what Helmut Schmidt had done early in his career. He got very strong effects, but he would go through a lot of people to find people who could do it and kind of eventually move towards people in the martial arts. Because the martial arts are people who have strong attention, and most of that attention is associated either with combat, so that the attention is focused outwards, and they're kind of used to pushing outwards mentally, or sometimes meditators, because the task involves attention. In fact, most of these psychic tasks involve some form of focused attention. The person who had ADHD probably would not be a great subject in this experiment because their minds might be wandering too much. So if you select people who believe that they can do mind-matter interactions, you may or may not find that they can. And the reason is, like with a lot of psychic experiments, people have spontaneous psychic effects all the time. They might experience a synchronicity or something else. But when you do this under the demand characteristics of a laboratory experiment, that's no longer a spontaneous effect.
No.
And if you don't know what caused the spontaneous effect in the first place, you go to the laboratory and now you have the anxiety of having to do something on demand, and generally it like goes away.
Yeah.
And so they go away disappointed, and we go away thinking, well, that was a waste of time. So the idea of testing lots of people and selecting ones who appear to have the right practice and the right predilections and interests and so on, that tends to be pushing in the right direction.